All right, now we're on part two. So if you haven't watched the part one video, you may want to go and watch that first here for section two on linearity, intercepts, and symmetry. And we'll start with a review question. For a linear function, what is the parent function or parent equation of a linear function? All right, hopefully you got that correct and you knew it was f of x equals x or y equals x is acceptable. And let's get going today. And so symmetry. Now I don't draw extremely well, and so I left a lot of what the book has in our notes today. And I'm going to try to go through it for you so that you can be on track here. And so a figure has symmetry. We've had symmetry before. You know, you've done reflections and translations and rotations before in other classes. And so those are all examples of symmetry. And so we're going to focus on line symmetry and point symmetry today. And so if you could put a line, and this is the line that the book put in, that split it in half so that this would reflect and they would be the same. So you could turn this over here, flip it over, or you could fold it up and they would be on top of each other. That's line symmetry. If you could turn it, if you could take just this half, and when you turned it 180 degrees, it would be right where the other half is. All right? So if turning half of it 180 degrees led to the other half, that's called point symmetry. And so you're going to have to try to identify line symmetry and point symmetry. Now, it is very possible that a graph would have no symmetry. I should point that out right now as well. But we're going to be checking for line and point. Next, we're going to be answering the question is the function even or odd? And there's multiple ways to do this. The first is just through symmetry. This one has line symmetry. That line splits it, so I could fold the piece of paper up and they would be on top of each other. And so it's even function. Right? But the other thing I want to kind of introduce right now before I talk about odd function is counting changes in direction. So for the changes in direction, I always add one. So this graph goes down and then back up. So it's got one change in direction. I always add one. All right. So 1 plus 1 is 2. That means it's probably got a degree of 2, which is an even number. So it's an even function. So you can know it by line symmetry, or you can count the changes in direction, add one. Odd, point symmetry. This has point symmetry. This would rotate down here. We just looked at an example like that. And so it's odd. This one is kind of hard to see because they've got the graph so small here. It's going up, and then it starts going back down, and then it goes back up again. So it goes up, down, up. And so that's 2 changes in direction. You always add 1. 2 plus 1 is 3. So this is a degree 3 problem. Well, 3 is an odd number, so it's an odd function. And so those are 2 different ways you can identify even and odd functions. Let's get to some of the examples. Here we're just asking for symmetry. So it's just point or line symmetry or none. So the first one, if I drew it in half and folded it over, that wouldn't work. If I put a point right here and spun it around, now this might be not as long as this, but it goes on forever. So it goes on forever. So eventually it would fold over and be equal, or spin over and be equal. And so that one is an example of point symmetry. Here, if I spin it over, it definitely isn't working. Point symmetry just 100% is not working over here. Is there a place I can draw a line that would fold it equally? Well, if I draw a line like right here, it would fold and would be very similar, but this dip would be still a lot bigger than this dip. And so this is an example of no symmetry or none, right? And then this one, you can probably already see a line could go right here. It would split it into 2 equal parts. And so this is an example of line symmetry. Give it a try here. All right, give it a try here. There's the options. Take a pause, give it a try. All right. So hopefully you got this correct. The first one, A is going to be a no symmetry example, neither point nor line work. And then B is a point symmetry example. All right. Let's look at even and odd functions. And so the one on the left here is a little bit tricky as far as looking at symmetry. So maybe you're going to count changes in direction. Goes up, down, up. Changes direction twice. Remember, it's change directions plus 1. 2 plus 1 is 3. 3 is an odd number. Now, it does have point symmetry. I could spin this over and it would just be on top of that. It's kind of hard to see, but it does have point symmetry, so that makes it odd as well. This one, maybe symmetry is what you first saw. There's a line splits it into 2 equal parts, and so that makes it even. Or let's count changes in direction as well. It goes down, up, down. So 1 change, 2 change, 3 change. Always add 1 and changes in direction. That makes it 4. So this is a degree 4. 4 is an even number. The last way you could use is called end behavior. We haven't talked about that yet. But end behavior, if it's ends or starts, begins, however you want to think of it, one side ends going one direction, the other side ends going the other direction, it's going to be odd. They both end going the same direction, it's going to be even. And so we have like 3 different ways to identify odd versus even. So give it a try. Is this an odd, even, or neither function? All right, hopefully you were successful. Hopefully you identified this as an even function. It's got line symmetry. 1 change direction means it's degree 2. And then the end behavior both go the same direction. Again, we split this section in 2 parts. So if you didn't finish this first part, go back and do that. You're going to do on this page 20, 21, 19 through 24 all, and then 31 and 32. For these problems, though, 22, 23, and 24, it gives you a lot of instructions in the book. I just want you to identify, is it even or odd? So that's for those 3, that's all you have to do. Good luck.